that's what happens when you get a little bit of outflow wind coming in and a lightweight tripod, and those two do not, they don't mix. Fortunately, the camera survived just fine thanks to, I guess, Canon's manufacturing quality, whatever, but no damage, just kind of a quiet night here. We've cleared out those thunderstorms we had earlier, and just a very pretty sunset. I wanted to talk a little bit about the some chroma key light here. Figured I'd talk a little bit about the AWOS. I didn't really get a chance to go into much detail yesterday because we were in a huge rush about that. And let's start that off. And you remember this from yesterday. Hold on, give me just a second here. Okay, this is the AWOS site that we had yesterday, and before I go much further, let me take a look at the chat and check for any audio problems. That would suck to get about 10 minutes in and find the mics off. Andrew is here, says good morning, beautiful evening here in Peoria. Looking for some rain there tomorrow night, for sure. Michael Koshine is here from Wisconsin. Sue M. wanting to know if it'll rain on Friday. Fun with Tech has just joined. We got VHC Media here in Las Vegas, windy, which tells us we've got some dynamics working through that area, possibly. Got Victor Cabot here, and Mike Wan and Alexi Pink. Ryan Toomey's interesting camera action. Yeah, that could have gone a lot worse. Kevin McKinney's here, Brian Harp, and Brian says video sound is 100%. VHC Media says audio is good. Dorothy Tornado's here. And Caleb Sluha, Iowa, ready for chasing tomorrow. Okay, let's get the little AWOS thing out of the way, and we're going to start out with a little bit more of a detailed picture of how all these instruments work here. So let me start these little modules. I've kind of divided up the video here. And this is actually an AWOS site, to be technical. AWOS is a slightly different version. It's kind of a cheap version of AWOS. And let me show you all the weather sites that use it. Had a link up earlier today. Let me, I can bring that up here. Okay, here it comes in about 5 seconds. I just got to paste it in here. Here it comes, and let me switch the video over. Okay, this is looking specifically at Texas for an example. So you can see a listing of all the different AWOS sites that we have here. And you can see some of these are the first-rate AWOS. That's kind of the Cadillac of all these. There's College Station, they've got one. Conroe, Corpus Christi, Corsicana. And the one we looked at yesterday was this station right here, Palestine. And you can see that's an AWOS-III. So that's kind of an upgraded version of AWOS. So, and you can see there's a lot of these AWOS sites in here, so it's kind of good to be familiar with a little bit of this technology. So we'll start on the wind here. There's the wind. Got the cups, the anemometer over on the left and the wind vane on the right. And they're designed to work in winds of up to 75 meters per second, which is about, I think about 140 miles an hour or so. The newer sites, they actually have a different technology for measuring wind. They don't have moving parts because, as you can see, these things will freeze up if you get freezing rain. And if you're depending on divergence fields and that kind of thing, you will see those fields messed up big time in a freezing rain situation. So you have to kind of be aware where the data is coming from and how it's being collected. Then we've got the temperature sensors over here, and this is an aspirated temperature and humidity sensor. It goes up the tube, and you hear that little fan. It's pulling in the air right there. and blowing it out the bottom of that side. So that's the technology we use there for picking up the temperature and humidity. And then we have the salometer, and that's this cabinet thing in the foreground. And notice that it's tilted just a little bit, like about 10 degrees from vertical. That's because it shoots a beam up directly up into the sky. It measures the time it takes for it to return using the speed of light. Now, if you tilt the beam just a little bit, then you don't have problems with heavy rain like we get here in Texas. It can cut through that just a little bit better in IFR conditions. The beam is 905 nanometers, which is kind of in the near infrared, so you can't see it. You're not going to be able to go out to the airport and see the beam coming up off these things. But it reaches 25,000 feet there, and the cabinet has heaters and fans to keep rain and ice off the glass. I don't know what it does about bird poop. I guess a technician has to come up and deal with that. Then we've got the visibility sensors. You see those little tubes up at the top here? They shoot a flash, kind of like a camera flash, into that little volume in between. And it's only a little volume of like, I think maybe 10 to 50 cubic centimeters, something like that. But it uses that to kind of determine the visibility for the whole airport area. So if something is wrong, if you've got like fog sitting over the sensor, over the site right there, but not on the runway, it's going to detect an obscuration to visibility for the airport. So you have to keep that in mind. It's not like it scans the horizon to see what's going on, nothing like that. Okay, then we've got the rain gauge, of course. And I didn't get a chance to check on this, but I think it may be a tipping bucket here with a heater. But it feeds that into the logic board, and it's able to use the inputs to kind of figure out what kind of precipitation has taken place. This does not have the more advanced AWOS type precipitation detection. What it uses is this little detector up here at the top, and it detects when precipitation is hitting a pad up there and changing the electrical characteristics. So from that it can kind of make some assumptions what kind of precip is falling, but it's not as good at detecting what type of rain is coming down. Okay, and that's about all I got for that. And the the equipment in the AWOS sites are a little bit harder to find than ASOS, so I might be a little bit off on a few of these details, but the general idea is correct. And feel free to check that out on the internet and learn more about these and pass back anything that you find that's interesting. Oh, I forgot to mention there's a barometer in there too. It measures station pressure, converts that to altimeter setting, and at some stations it will convert that to sea level pressure. That's not available at all stations because it requires a bunch of climatological values. But where it's available, you will get millibar readings. Okay, time to go into the maps here. So we started here with the SPC forecast, and we can see we've got a marginal risk for the northern plains right around Nebraska. And when we see that, that's kind of a good indicator. We've likely got kind of a stationary boundary in that area, or maybe outflow from an MCS, and possibly some upslope flow. So maybe a little bit of air coming like that. And I'm kind of guessing here based on last night's weather and just from experience, because I haven't looked at the weather. I kind of jumped right into this. It's kind of fun to do things that way, and it's kind of a good way to learn how a forecast is put together. And we've got this one little area also around Ogden, Utah, down into central Utah there, so maybe a little bit of steep lapse rates in that area. Pretty quiet here in Texas. It's starting to look a little bit like summer. High pressure along the Gulf Coast here, and we've got southerly winds coming up from the Gulf. So the Gulf is open. And how is that moisture supply? Fairly good. We're picking up the green shading here, which means 60-degree dew points, and even the darker, nope, no darker green shading. So these are mostly 60s dew points up here. And you can see the moisture axis is in this area, just slightly east of I-35. And the wind field is pretty weak, so moisture advection is not very strong right now. But you see the dry line here. We don't use the red lines. We use the blue lines, which are your dew point. So we can see a little bit of packing of blue lines right here, and a little bit of packing right here. So which one is important? You always want to go with the moist one. So that's going to bring our line way over here. So you're going to pick that for the dry line, but definitely keep an eye on these other ones, because on rare occasion you will get development along those secondary dry lines. Okay, so we're going with this for now, but you notice this bullseye appearance here. That can be an indicator of maybe a problem at a station. That would clue you in to go and look at the observation maybe. Maybe consider equipment problems, kind of like what I was showing you at the very beginning of the webcast. A good tool for looking at that is going to be digital atmosphere, or you can use your favorite surface analysis website. I'm going to pull some data down here and see what's going on. And while that's working, we're going to look at the rest of the surface analysis picture. We've got a few thunderstorms out around the Arkansas, Louisiana area, and we had some earlier around the Dallas area that moved up from East Texas. And this is all due to kind of a trailing cold front boundary that has been sitting in this area over the past day or so. And you see this little trough in here? That's probably a good indicator where it is. So I might be looking at something like that, perhaps. Okay, plotting the conditions. Let's see here. Down to Texas here. Going to increase the density of stations a little bit. And let's see, what do we have here? I don't see anything here that would bullseye those readings. Could be because that was the last hour feeding into that that field here, but that would be something I would kind of watch right there. Now there is a little bit of this packing of dew point lines a little further east. So looking at that, I would actually probably maybe go with a third possible line, maybe something like that. So you can see dew points on this side around 58, and dew points like right here around Waco, 66. So this could be an important boundary if storms are expected to fire. So you would probably consider all of these. And if one is not going to be important, you can certainly discard that. Looks like probably a dry line down in Mexico too. So let's take a look up to the north, because I know that's going to become part of the forecast picture here in the next day or so. Okay, so we can see a little bit of a triple point possibly. Let me see if I can move that over a little further. Okay, so this will look at the Central Plains here. So hopefully you can see that all okay. Now to find the cold front, I'm going to kind of depend on the wind field and the temperature, which is going to be the brown wind barbs and the red lines here. So probably going to be looking at something like that here for the cold front. It looks like something is stalled out right here. If you want to, you can look at the wind field too. You can plot streamlines. So looking strictly at like that, I see a pattern kind of like this here. Kind of the streamline picture here. So probably a little bit of a frontal boundary through this area, another one out to the east off the top right, and in here looks like maybe frontal boundary being broken up by some high pressure, possibly a little bit of ridging in that area. Anyway, there's a frontal boundary right there, and it looks like maybe a dry line right through about this area. And this would be the triple point, just north of Russell and Hayes. Okay. So if I was going to be chasing and I had no data to go off of, I would probably target this part of Kansas right here. All right, let's see. Let's take a look out to the west. We haven't looked at that very much, but we have a front moving through that area. Now, of course, the fields are getting disrupted pretty severely by the terrain, so it may be beneficial to look at the plots on this instead. However, I can see some troughing through this area right here. So I think this is probably our frontal boundary. I see probably a lot of thermal packing in this area here. Very strong thermal gradients, so I think this probably represents our front here. So that would explain a lot of the precip that we have going on in the Salt Lake City area there. So some good frontal lift working on that area. Okay, so we started out with the surface chart. Now we can take kind of a top-down approach. And let's check it out here. High pressure over the central U.S. and troughing coming into play on the west coast here. You can see like 120 knot jet max out in the Pacific. Here's that jet stream coming on shore. Coming onto the coast near San Francisco, up to Montana, and then over to New York State and New England. And we've got this little trough over Texas too. So that's helping to generate a few of the showers that we have here. A little bit colder and more unstable air in that part of the country. So we've got height falls moving in and stronger flow. So that should destabilize things starting with the Great Basin and Central Rockies area here. 500 millibar flow showing some of that stronger flow coming into the Central Rockies area. There's some ridging that's impacting the northern plains right here, probably helping to keep things kind of shut down in this area. But this area here, this is all starting to destabilize. And we can pick out that little upper level low right there over North Texas this morning. 700 millibar. This is up at 10,000 feet, and this shows a little bit of the cap strength. Values that are over 10 are frequently associated with a very strong cap. And when you get down into the 10 to 8 degree range, that's where you kind of start to transition over to a weak cap. And we can see capping is a bit on the weak side. Of course, that does depend on the surface temperature and dew point, but 10 degrees is kind of a good rule of thumb there. And then finally at 850, we can see some 30-knot flow coming up from the south. 40 knots at Dodge City. So maybe a little bit of a low-level jet coming up. And then elsewhere, like a bit of a ridge at 850 affecting Texas, Oklahoma, and Arkansas here. Okay, let's take a look at, let's see, the radar maybe. I'm going to go to College DuPage this time for the radar, since I don't really have a site in mind to look at. I'll go to weather.cod.edu. And College DuPage, it's one of my favorite online analysis websites. Just go to Weather Analysis Tools, click on Radar. And for the broad scale synoptic pattern, you can look at the 2 kilometer or regional products. Then for a closer look, you can use the 1 kilometer here. And that gives you a radar mosaic. So it looks pretty quiet on the plains. Only some showers along that front in Utah, and this residual moisture out around Arkansas and Louisiana. I'll take a quick look at those showers in northern Louisiana. They've got a couple of fields at the very bottom that you can add to your analysis. Now keep in mind that a lot of these you can see on the page that the source of the data is not really explained, and anytime you go to a website where that's the case, you have to be a little bit concerned, because it's good to know where your data is coming from. Now I'm guessing that these came from the rapid refresh model, perhaps. And so since we don't know the source of data, we can just kind of use it for general guidance here. And we can see CAPE values around 1,000 to 2,000, so it looks like some decent instability in northern Louisiana. And then I think these readings here are being impacted by the cold pool with the shower activity. So that's probably feeding into the models there. So what you want to kind of use for severity is use the clear air regions. So we know that these showers here, they're probably in an environment with maybe 1,000 to 1,500 joules per kilogram. And then this area here probably in slightly more unstable conditions, more around 2,000. Okay, then here's the satellite, always interesting this time of year. And when that finishes buffering, there we go. You can see the showers coming up out of East Texas. You can see that southerly flow coming from the Gulf. Looks a lot like what we see in late summer with a sea breeze rolling in. A lot of times it'll come on shore onto the coast around late morning. It'll move through the Houston area around lunch and then move towards the Lufkin and Waco area towards evening. And then sometimes it'll make it all the way up to Dallas, but not too often. So this kind of looks like that pattern. But we do know that there has been a front that kind of pushed down into this region, and it's kind of stalled out. And there's that shower activity there in southeast Arkansas. Here comes our instability. You remember where we had that ridge drawn on that upper air chart? That was for this morning. And we had that ridge kind of in this area right here. And you can see earlier today, this is the area downstream from the ridge. It's pretty clear. just a little bit of low cloud up in this region right here. And on the other side of the ridge, you have the cirrus, kind of heralding the arrival of instability and colder temperatures aloft. Okay, let's see what chart we have up next. Yeah, the thermal analysis. This is mostly a chart we use during the cold season, but it is helpful in April and May, and often in August and September. And we can definitely see the frontal system there in the Great Basin area. So that matches up pretty well with what our surface chart showed. And then maybe that stalled out front, maybe in this area here. And it looks like maybe some other boundary right here through Illinois. But here comes the next system in Wyoming, and that'll be moving across the Dakotas and Nebraska overnight. And we'll see things starting to become active. Okay, for the soundings, let's take a look at the Central Plains, maybe Topeka, downstream from that ridge. So we can tell that this is a morning chart because we've got 12Z. We can see a little bit of capping here. Not a whole lot, and the capping is mostly centered down on this layer, down around 750 to 850. The capping was a little bit higher. We would see the temperatures come up a little bit at 700 millibars, and that would be more on the order of about 7 to 8 Celsius. And if we had a cap kind of like this, you can see 700 millibars above 10, that's about 10 or 11. And we would be seeing a pretty strong cap with a situation like that. So if we had enough moisture in the low levels and plenty of heating, we would be thinking about maybe tornadoes with enough lift in a situation like that. Okay, southerly flow up at Topeka. We've got the winds coming out of the south there. We'll take a look at one more station. Maybe, I guess Fort Worth is good. We see not much of a cap there. Looks fairly tropical. Moisture all the way up to about 18,000 feet there. You can see a little bit of that high level cirrus up above 30,000. Okay, I guess we'll take a look at the dynamics here. Okay, so this is going to be the current chart here. It looks like our upper level low is somewhere around Houston. And then the jet is starting to come on shore here around Los Angeles. So it's actually moved south a little bit during the day. We're seeing the axis of that coming into Utah. Matches up pretty well with the surface front, which is in that area right there. And then the rest of the jet is going up through the Great Lakes, up through the UP of Michigan, right there where we have 50 knots. A little bit of energy working there through the Lake Superior area. So here comes the next system, and starting to get some of these short waves moving across the Rockies and the Great Basin area. So over the next day or so, going into tomorrow, by the time we do the webcast tomorrow, got a pretty good wave moving through the Dakotas. There it is right there. Polar front jet through Nebraska up into Iowa and Minnesota. You can see the wind speeds coming up quite a bit there in Iowa and Minnesota. So keeping in mind the relationship of the trough and the ridge and the jet axis, our frontal system is going to be something like, probably something like that right there. So this is a first guess, so we're thinking maybe for tomorrow evening, if we get enough moisture, possibly southern Minnesota and Iowa for storms tomorrow. Maybe even back towards the river here. Not sure what river that is. It's the one that goes up through South Dakota. I want to say it's the Red River. I can't remember. Anyway. Okay, where are we at? Okay, let's go on to Thursday. When we do the forecast on Thursday, here's that negative hill trough coming in. Strong jet stream energy plunging southward into the Four Corners area. The other system up in the northern plains moves up into the Great Lakes area, so affecting mostly Ontario there. And then for Friday, now we've got a whole lot of jet stream energy and upper level lift affecting the central plains here. So things will be opening up on the plains probably Wednesday, and then Wednesday and Thursday, and then by Friday, things should be going full scale here. Anywhere from Oklahoma north to Kansas, maybe even into Minnesota and Arkansas there. And we can see towards the end of this 10 a.m. run, like that trough is kind of moving south a little bit here. Okay. So I think that probably takes us into the GFS. Let me get that centered. Okay, let me check in on the chat here, see what's going on. Find my place here. Okay. Brad up in North Dakota mentioned snow up there. All gone, though. Justin Pulliam asked about the special episode. Yeah, we covered a little bit of ASOS and AWOS. Ryan talking a little bit about large hailstones. Justin Pulliam asking about an episode of Digital Atmosphere. That's definitely an idea. I think way back in the archives, if you check the channel, I've got I think maybe an hour long, kind of like a tutorial on using Digital Atmosphere. So if you dig in there and do a search, I think that will come up. So check around for that, but I probably should do another one and also do Rayab and some of these other tools. Okay, Iowa, Illinois under a threat tomorrow afternoon. And time frame for Chicago, O'Hare, Midway. Don't have a time frame yet. I know it's going to be sometime tomorrow evening. But that far out, we're going to be just kind of depending on the model for that. So we'll see what that has for tomorrow night. So running through the charts, let's see here. We'll go on to tomorrow night. 0Z when we do the webcast. There's our fronts for tomorrow night. So something like that right there. And you can see the Gulf is open. Pretty good grading over Texas and Oklahoma. Probably a low-level jet being supported. And the moisture flow coming up like that. From Dallas-Fort Worth, Oklahoma City, all the way up to Des Moines and the Quad Cities area. So I think based on this initially, during the evening, most of the impact will be on Iowa. Not too sure how far east or west, but somewhere in Iowa. And possibly maybe a few storms in the central Illinois area, depends on how much moisture. And then it looks like lift will be increasing in the Chicago area during the evening. Let's see here. 10 p.m. looks like the warm front is going to be moving up towards Chicago. GFS breaking out some heavier convective precip in eastern Iowa. I think based on this, I think the main impact on Chicago will be late at night or possibly during the morning on Thursday. There's the front right there, breaking out a little bit of precip in the Kansas City area overnight. And then during the morning, we're looking at this right here. Looks like the main axis of moisture by Thursday morning, mostly heading up towards Indiana there. And the front lifting north of there, so I wonder if they might escape most of the storm activity. For Thursday, when we do the webcast, warm front up in upstate New York, cold front through Ohio and Indiana. We'll see storms redeveloping in that area. So probably coming together around Indianapolis up to Detroit and Toledo. Let me correct that front a little bit. Maybe a little bit like that right there. So storms going up along that cold front right there, and then we have an inclusion going up into Lake Huron, and then cold air blasting back in behind that. High pressure over the northern plains, and then down in the southern plains, looks like we have a front coming together in this area right here. Maybe a bit of a backdoor front coming into the Red River of Texas, Red River area. So let's see, when's the best chance for chasing on Thursday? Well, this area here is going to have quite a bit of upslope, so I think the main action area would be on the Raton Mesa on that day. And then we do have some sort of boundary in the Red River region, so see the GFS trying to break out some precip around Durant and Fort Smith. We'd have to watch for something there. But Friday will probably be the main storm day, and we can see this. This is the time of the webcast on Friday night, so we'll probably be running a special webcast on that day. Very strong photogenesis in that area, and we can see the impact of the low-level jet and moisture axis affecting mostly the I-35 corridor. So Oklahoma City and Muskogee and McAllister, pretty much under the gun according to the GFS there. Then we go into the overnight period, and we've got things moving eastward into Arkansas. So probably a stormy night around Fort Smith there. Front coming in East Texas, looks a little bit dry there, but looks pretty stormy there for Little Rock and Fort Smith and Memphis. Then when we do the webcast on Saturday, front moving through Mississippi and Louisiana right there. Warm front in Tennessee and North Carolina. We're tapping the Gulf a little bit, kind of like this. So most of the intense storm activity, I think, will focus on this low pressure area and the warm front. So Nashville, probably some severe risk for Saturday there. Then on Sunday, things move towards the coast. So here we're looking mostly at North Carolina and Norfolk for any severe weather potential. Ridging coming into the Midwest and the Mississippi River Valley. Lee side troughing coming into play in Colorado with this very deep low in Montana. Fronts of around with that low looks something like this right here. Looks kind of like a cold occlusion, kind of rare for the plains. That's probably because we got some really cold air kind of meeting up with that system right there. Pretty quiet in Texas and Oklahoma to start the week out. Tuesday, same thing. You can see the Gulf is not quite open just yet, even though we have southerly flow. So this is basically just tapping Mexico and West Texas there. So kind of a dry Monday. But things should start changing maybe Tuesday and Wednesday. See, now we're starting to get some flow out of the Gulf there. So late next week looks kind of like a repeat of this week. And then stormy towards Thursday and Friday. It's funny how these weather systems always work out on a calendar basis. It's always the weekend instead of the middle of the week. Because here we are on Friday, Saturday, storm system in Mississippi. Kind of crazy. That's been happening for a while now. But GFS going for a very deep system up there in Lake Superior. So something like that right there. And that might be one of the last shots of winter there coming into May 1st there. Okay, let's see. One more look here at the chat. And Charles asked, do I only look at GFS before high-resolution rapid refresh is available? Depends what I'm looking at. GFS is mostly a long-range model. But for this webcast, I'm kind of using it to kind of give you an idea what's happening synoptically over the next 7 days. When we have a major severe weather event, then I'll start bringing the convective models and the mesoscale models into these forecasts, and we'll look at that a little bit more. But for now, during these periods of fair weather, we'll look mostly there at the GFS, and it's certainly good enough for that. Okay. That's probably about all I got for today. Hope you enjoyed the webcast there. We'll see you tomorrow, and have a good evening, guys.